Today we're going to look at ways to attach an object to a curve. So you see here we have a curve. If I select its CVs, move it around, you can see that that locator is attached to the curve at that point. And then I have another object that is linked to that locator that I can move independently. Here I've got some expressions that are driving this. So I'm going to talk about common ways for doing this, and then an adapted way of tackling this problem based on tutorials from other people that I've combined here. I'll be sure to link their work in the description and in the video. So I'll just create a new file and we'll start again. So we need a curve. So I'll just quickly create a curve and something to run along the curve. For our purposes, we're just going to create a locator. And there we go. So if we want to have something move along a curve, that's pretty straightforward. We can just select the locator, shift select the curve, constraint, motion path, and I can just leave everything at the default settings, and it will use the time slider to move along the path. Its front axis of the locator is X, the up axis is Y. Lots of other settings. Now if I just play my animation, we have it moving along. So that's fine. That's probably something most people who use Maya know. There's a motion path node, and if we want to, we can take a look at that in the graph editor. Just have to make sure we select the motion path node, and then it shows up as the animation in the U value. So the U value is the beginning to the end of the curve, no matter how long the curve is. So it's just a single dimension. If we select this curve and go into the shape node, you can see that the min-max value is 0 to 3. Its number of spans is 3. It's probably easier if we switch this from 0 to 1, the min-max value. So I can just rebuild the curve and go to modeling, curves, rebuild, and then just set this for the parameter range to be 0 to 1. Just leave the num spans like that, and now you can see it just goes to 1, and it should still work. Maya should figure that out. Yep. So let me select this again, and the motion path. Now we can see it here. So essentially what this is saying is that at frame 0 or frame 1, frame 1, we're at a U value of 0, and by frame 120, we're at a U value of 1, which is at the end of the curve. So if you want this to move more slowly, you can just drag out the end keyframe to a higher frame number, and then it just takes longer to complete the 0 to 1 in U. Okay, so now what if we want this to just stop in one spot? Well, you can add more keyframes to this U value animation curve. Let's click on the Add Keyframes button, and you can change and alter this. So now this is going along 0 to 1, gets this far, goes backwards, starts going forwards again. And you can see that other keyframe is in there at 75. I don't have enough frames right now to see all of that, but you get the idea. So we can use this idea of setting keyframes in the middle of this curve as a way to lock it into position. So if we want to lock it into this position, we can set a keyframe at that time and then simply delete the first keyframe and the last keyframe. And now there's no animation, but that animation curve, that keyframe, is locking it into place. So that's pretty good. And this is a pretty common method to do something like this. It's a bit of a weird workaround. Maybe there's something built into Maya that I don't know that does this automatically. But let's look at other ways to do this. So I am going to select that motion path and just delete it. So now we don't have these connected in any way. Back to our curve and our locator. So I found a tutorial when looking for a solution about this. by somebody named Zeth Willy on Vimeo, and describing how to use the point on curve info node to achieve almost the same thing, but maybe to give you a little more control if you had to do this many times. And I'd advise you to go take a look at his video. It's great, and I'll link it in the description, because he goes on to describe how to write a Mel script to automate this process to make lots of these curve info nodes for attaching many objects to a curve. But we'll do just the introductory part here. So if we select this first command, it's just creating a node called point on curve info, and let's create it so you can see what it does. Just enter, and now it creates a point on curve node, and you can see it's asking for an input curve, and we will attach this one eventually. And it just records the position, the normal, the tangent, curvature center, curvature radius, based on the parameter, the 0 to 1 value that goes from the beginning of the curve to the end of the curve. Now, Zeth Willy has a very useful other way of creating this node, because when you create this node, it doesn't really go anywhere, and it's kind of hard to find. If you wanted to find this node now, if I deselected it, it would be a little bit hard to find, doesn't show up in the outliner. If we go into the outliner and turn off DAG objects only and did a search for curve, point on curve info node will show up here. So it is in the scene, it's just not that easy to find. So as an alternative method, I'm just going to open up the script editor. So typing this down here or in the script editor is the same thing. So here, this is a command to create a new shading node, and this is a flag to declare that it's a utility type node, so it'll be categorized and classified in that way, and placed in a way we can find it. And the type of node is this, the one that we just created, and this gives it a new name, and that new name is curve info, and we end it with semicolon. Just going to paste this in here. And just because I've done this a few times in preparation now, I'm going to just give this a new name. I'll call this demo CI for curve info, and just select this, right click, execute. So now it's created a new node, and we still don't see it in here, but if we go into the Hypershade, because we declared that it was a shading node, under utilities, there it is. So this is an easy way to find it. So thanks to Zeth Willy for that great tip. And again, I'm just following his tutorial here and combining it with one other. So we want to connect that curve to this node. So to do that, we'll need our connection editor. So general editors, connection editor. And we want the demo or the curve info node to be on the right, and then the curve to be on the left, because this is the one providing the information. The one on the right is the one taking the information. So we want to find world space. And if you don't find world space in here, it probably means because you don't have the shape node selected, but instead you have the transform node. So I'll just go to curve shape over here and select it just to make sure. And there's no search option in here, so just have to scan until you find world space. I probably passed it already. Oh, I have to reload, that's why. Didn't see it. I think it's down here somewhere. There it is. World space, and connect that to input curve. So now if we select our curve info node that I've called demo CI, there's the curve shape connected there. So that's good. And now you can see it's gathering information from that. So now we can use the position information at parameter 0 to drive the position of the locator. So we'll use our connection editor again. This time we want the curve info node to be on the left, and we want our locator to be on the right. This time the translate node is fine. And here we have to find, is this the right thing? Oh, no, that's the curve shape. So we have to Sometimes to make sure you select something, you select the node, then click select in the attribute editor and reload left. And we want to connect result position to the translate of the locator. Right? You can see what's going on here. So now if we just take a look, now you can see the locator is on the curve. And if we go into the demo CI, the curve info node, and we change the parameter to 0.5, then it goes halfway along. I can't remember now that whether I've mentioned this or not, but if you want to double check that your curve goes from 0 to 1, you can select it, curves, rebuild, and parameter range 0 to 1, number of spans stays the same. And we should have that. I think I did say that already. Okay, so now one thing we don't have, well, what I should say first is now this one is just locked at whatever parameter number you put in here. So if we adjust the curve, then the object stays right where it is. Now, if you wanted to, just since we're here, if you wanted to animate this along the curve, you could do that with that curve info node that we created and just set some keys on parameter. Now we'll keep getting these warnings, but it seems fine. So at frame 1, I'll just put the parameter to 0, set a key, and then let's say frame 45, we'll set the parameter to 1, set a key again, and it will move along there, right? So that's good. So it gives you the freedom to do that, but you'll notice it doesn't point along the curve. So really, if you were just doing this for one locator on a curve, just use the motion path. It's much easier than this. But this is another way to link an object to a curve without the motion path. But again, since we're here, if we want to point this along the curve, we can use a constraint for that. So if we select the curve, shift select the locator. So select the curve, then the locator, and we'll go to animation, constraint, and we want to use a tangent constraint. And at the default setting should be fine. Although if you're using something other than a locator, you might want to alter what the aim vector is, the part that's pointing down the curve, and the up vector, the axis that's pointing up from the curve along the world y-axis. Now you can see it's following along. So that's pretty handy. So we can kind of replicate what the motion path is doing if for some reason we wanted to do that. Yep, so you can still see it's pointing along. Okay, so now we've done that, and thanks again to Zeth Willy for that great tip. But now what if we want to attach an object to this? And well, I guess first we want to answer the question, why wouldn't we just attach another object directly to the curve? Well, you could do that. So let's say we had a torus, and we could do all these same things with the torus, with the motion path, or with the curve info node. But it gives us a little less freedom because we may want to animate the torus independently while it's moving along. And if it's linked to the curve by those connections into its translate attributes, we're limited to a certain degree. So there are two ways you can attach this torus to this locator. And one is to select the locator, shift select the torus, and go to constraint. And we can use a parent constraint. I'm just going to turn off maintain offset here. You can see it'll pop over there and it will follow along. So that's great. I'm going to undo that. Get rid of that constraint. And the reason that we're not going to use that in this case is because we want to animate the translation and rotation of this torus. And you can do that with a constraint, but it actually introduces another level of animation with something called a pair blend that we'll talk about at another time. So a simpler way of doing this is simply to make this torus a child of the locator. So I'm just going to move it into position by holding down C, middle mouse clicking and dragging on the curve just until we get back to the beginning, right where the locator is located. And then we'll take the polytorus and just middle mouse drag it on top of the locator, and now it's a child. And so it will follow the translation, rotation, and scale of the locator. But if we open this up and look at the torus, here we can see that the translate X, Y, and Z are not controlled by anything, and rotate X, Y, and Z are also still free. So we can control these in other ways. So what other ways? Well, we could just set keyframes. So if I set a keyframe on Y, I'm just hitting S on my keyboard. Just adapted my shortcut to be like that. Did I set a key in the middle? Yeah. Right, so we have the freedom to move this around however we want. I'm going to break that connection. Or we could write an expression here. So I could right click on here, oops, control right click and go to expressions. And just say ptorus1 translate y is equal to sine times time. Or something like that. And then we should see, well, we can see it now that it stopped. It's going up and down based on that expression. So it's multiplying whatever time we're at. So that's what's driving the animation to change, and multiplying it by sine. But there are other better expressions we can put in there. And here's where we rely on the expertise of somebody else again. So I found on a website, Ronald-Fong.com, a great, simple, elegant little expression that allows us to give random motion around for any object. It would be useful in many cases here, but let's just take a look. So here we're just declaring a variable. So that's what the $sign means. Wiggle F equals 3, and this can be changed by the user. And the double slashes just mean this is a comment. So this is wiggle frequency. Wiggle A is wiggle amplitude, and wiggle V is wiggle per axis frequent variant. So just a randomizer, I guess. And so these are just declaring our variables. And now here is the expression that applies these variables and to translate X, translate Y, and translate Z of the object in question. And so what it's doing is using a noise command, and you can look that up in the Mel command help sheet. And it returns a value, I think, between -1 and +1 randomly. And then this is being multiplied by what's in these brackets times wiggle F, in this case 3. And then that is all being multiplied by wiggle A, again 3. And then you can see it's slightly different for Y and Z, using all of the attributes in different ways, using the inverse of wiggle V times wiggle A, and so on. So we'll just grab all this and copy it. And again, for the ptorus, we can just paste this in here directly, and nothing has to change because these are all unique variables that have been declared, and they refer to nothing specific, no specific nodes other than the one that this expression is in. So it will automatically refer to the translate X, Y, and Z of this node. So we don't get a red mark down here, so that's all good. So you can see what's happening here. And I think it might be easier if I just select this locator and turn off the animation for now. So I'm just going to break the connection here and just set this to 0.5. So you can see what this expression is doing. And if we just go into here, we can see the expressions again. So if we want it to be less frequent, sort of more gentle, can change wiggle F to 1. And if we want the amplitude to be greater, I'm going to wiggle A to 6, and then we can change this variant here if we want to. But if we just leave it as is, and kind of see it's moving randomly around. And there is also on that website a very similar description for rotate and scale. Now, if you wanted to have rotate scale in here and you wanted to have unique controls for these, and you do because the amplitude I think is in degrees, you would just have to change the name of these variables and change their name as they appear in your actual expression. So the Ronald Fong helpfully provided this great expression, and here you can see this is the one for rotation, but it uses the same attribute name. So if we have both of these in here, we'll get a problem because of the same attribute be declared twice. So we can just change the names here and change the names in here. So let me just copy this. And if I select this again, go to expressions. Oh, expressions is open. And we just paste this in, then you can see we'll have a problem because we're declaring the same variable twice here. So I'll just add an R for rotation to each of these, and then add an R wherever these variables show up down below. Okay, no errors, so that should be fine. And if we play the animation now, you can see that we're getting random motion on rotate and translate. Let's give ourselves a few more frames to look at. So this is one of the great things about Maya. It allows you to be technically creative. Also, one of the frustrating things about Maya is because it requires you to be technically creative. Luckily, there's a whole host, a population of people over time who have developed these clever solutions to common problems in Maya. So thank you to Zeth Willie and Ronald Fong for providing this information, and I hope this is useful to others. Thanks.